2 brackets in my denominator, and how many of those brackets have variables? 2. So how many non-permissible values am I going to get? 2. So I always get the same amount as brackets with variables. So I get a can't equal 0, and that one's done. Then I get a plus 1 can't equal 0. And I subtract 1 to isolate a. So a can't equal -1. So those are my 2 non-permissible values. If I plug them back into my original, my denominator will be 0, and I'll know I'm right. So I go 0 squared plus 0 is 0, so that's good. Then I put a -1. -1 squared plus -1 is 0. We look at C. C has 4t cubed all over 3t squared minus t. And I just rewrite the numerator because I don't actually care what it is. But then I ask myself, can I take out a GCF or a difference of squares of the denominator? Is there a GCF or difference of squares? Yeah, there's a GCF. What can I take out? T. So if I go 3t squared, take out a t, I'm left with 3t. Negative t divided by t is -1. And this t can go in its own brackets. How many brackets do I have? 2. How many variables in those brackets? 2. Each bracket has a variable, right? So I'm going to get 2 non-permissible values. So I'm going to get t can't equal 0. And 3t minus 1 can't equal 0. The t can't equal 0 is already done. The 3t minus 1 I have to solve backwards. So I'm going to add 1. And I get 3t can't equal 1. And then divide by 3. T can't equal a third. That's my second one. So when I get a fraction, if I worked it backwards, I always have a number with a variable in front, or the variable with a number in front. I end up with a fraction. You guys are going to try D, E, and F. Okay, D has -2x over 4x minus 8. Is there anything I can take out of the denominator? 4, so I take the 2x. And I put the 4, and then I'm left with x minus 2. The 4 goes in its own brackets. So how many brackets do I have? 2. How many brackets have variables? 1. How many NPVs am I going to have? 1. This 4 isn't going to cause 1, right? Because it doesn't have a variable. So I just take the x minus 2, and I set it not equal to 0. And I get x can't equal 2. And that's it. This 4 doesn't cause any problems because it doesn't have a variable. I look at E. E has -6x plus 3, and yes, I could take a 3 out of that, but I don't care because it's only NPVs, so I only care about the bottom. I have -3x minus 15. What could I take out of the denominator? A -3. So I just rewrite my numerator because I don't care about it. Take a -3 out, and I'm left with x plus 5. Because -3x divided by 3, -3, is x. -15 divided by -3 is 5. Now I have 2 brackets. How many of them have variables? 1. So this -3 doesn't cause any problems. I don't even worry about it. I get the x plus 5 can't equal 0. Subtract my 5 over. And I get x can't equal -5. And then F. So F has 4x cubed minus 2x squared all over 2x cubed plus 10x squared. So So the numerator, I don't care. I could take out a 2 and an x squared, but there's no point because it's just NPVs. If it said simplify, I would have to, but it doesn't say that. The bottom, I can take out a 2 and an x squared. Then I'm left with 2x cubed, take out a 2x squared is x, plus 10x squared divided by 2x squared is a 5. Now the 2 and the x squared, do they have a plus or minus sign between them? I don't know what I just did. The 2 and the x squared have a plus or minus sign? No. So they can be in their own brackets. So the 2 goes in its own brackets and the x squared goes in its own brackets. I have 3 brackets. How many brackets have a variable in it? 2. How many NPVs am I going to get? 2. Now, this 2 doesn't get me 1. This 2 doesn't get me 1. The x squared, I could actually write an x squared as an x times an x if I really wanted to. An x cubed would be an x times an x times an x. An x10 would be an x times 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 an x. Okay? So whenever you have x squared, x cubed, x10, x100, your NPV is always going to be just 0 because you could split them into just single x's. Okay? So x squared will get me an NPV of x can't equal 0. Oh my gosh, it's bored. And then x plus 5 can't equal 0. So x can't equal negative 5. Now I'm going to have you look at number 2. Number 2 says identify any equivalent rational expression. Equivalent means I do the same to the top and the bottom, correct? So I can multiply the top by x, but then I have to multiply the bottom by x. Or I could divide the top by 2 and I have to divide the bottom by 2, correct? Now, here's a hint. In number 2, 2 of them are equivalent and 2 of the other ones are equivalent. So you have to match the 2 equivalents to each other. There's 4 of them. 2 are equivalent and 2 are equivalent. Okay? You're going to try and match them. So I'm going to look at let's look at A and D for now. I'm going to show you the first one, and you're going to prove to me how the other ones are. So, oh, for goodness sakes. Okay, A. A on number 2 has 4x minus 4 all over 16x squared. D has 16x squared minus 16x all over 64x cubed. So I'm trying to see if they're equivalent. Well, they are, because I just gave you the 2 of them. So, of course they are. But how do I do it? So I can either go from the simpler ones and multiply the top and the bottom by the same thing to get to the other one, or I could go to the more complex one, divide the top and the bottom by the same thing to get to the other one. But you have to do the same to the tops and the bottoms. So if I'm going from A to D, what would I have to do? I'm going from A to D. I have 4x. I need 16x squared. What am I going to multiply by? I think someone whispered it, yeah. And I have 4x and I need 16x squared. And, yes. So I have times by 4x. Because I'm comparing this one here to this one here. You see that? So I need to multiply by 4x to get 16x squared. When I do the top, I have to do the bottom when it's equivalent. So let's see if we get D. So we go 4x times 4x is 16x squared. Negative 4 times 4 is negative 16x. All over 16x squared times 4x squared, or 4x, is 64x to the 3. Because you add exponents when you have the same base. So that's true. I want you to show me how B and C are equivalent. Try it out. So I told you that they were equivalent, but they don't look equally as easy to tell. The reason why I think this one throws people off a little bit is if you look at the right-hand sided numerator compared to the left-hand sided numerator, this one goes number minus x, and this one goes x minus number, correct? So what you can do is you can actually switch. I'm going to switch C around so that the numerator is in the same order as the B. So I'm going to go negative 8. You have to keep the sign with it. Plus 8x over negative 128x squared. Now you didn't have to do this, but I know that it's a lot more overwhelming when people try and look and they don't have the same variables per term. So now I have number term or number variable squared, number variable squared, right? They're in the same format variables. So now I have to compare them. I have to say, okay, I have the number 2. I need the number -8. Now I could divide that side to get to b, but I'm going to multiply to get to c because I like multiplying better than dividing. It's personal preference. But you could divide and be totally fine. So how do I get from 2 to -8? Yeah, multiply by -4. Now if they're truly equivalent, I have to do it to the top and to the bottom to get this. If I only do it to the numerator or the denominator and not both, it's not equivalent. Because to be equivalent, you have to multiply the top and the bottom by the same thing or divide the top and the bottom by the same thing. So I'm going to get 2 times -4 is -8. Negative 2x times -4 is positive 8x. And then -4 times 32 is -128x squared. Do they match? Yes, so they're equivalent. Do you see how they can be compared? I'm going to get you to do number 3. Number 3, I want you to tell me it's a multiple choice. So the rational expression 48x squared over 16x minus 4, I want you to tell me is A, B, C, or D equivalent to it? A, B, C, or D. So try that one out. Number 3 shouldn't have taken forever because the answer was actually A. So unless you picked random ones along the lines, you won't catch it. So if you look at 48x squared over 16x minus 4, this is different than simplifying, which we did on Friday. This is equivalent. Equivalent means what can I do to the top and the bottom that will get me the same thing. It's not simplifying. I don't have to make it smaller or anything. It's equivalent. So this is the first one, and then A, or that's the original, and then A was 12x squared over 4x minus 1. So I compare them and see what I can do. So I know I have 48x squared. I know I need 12x squared. So I know I'm going to divide by 4, correct? And when it's equivalent, you do the same to the top and to the bottom. That is what equivalent. And you will read it on your test. It will say determine the equivalent rationals. It will say equivalent. And that means multiply the top and bottom by the same thing or divide the top and the bottom by the same thing. So I could either multiply this one by 4 or I could divide this one by 4. So if I do it to the top, I have to do it to the bottom, and then it just goes away. So 48x squared divided by 4 is 12x squared. And then I go 16x divided by 4 is 4x. And then 4 divided by -4 is -1. And they match. So they're equivalent. So that's A. So it's what you do to the top and the bottom that can get you the other one. Okay? Now, number 4 is a bit backwards. It's giving you the NPVs, and it wants a rational. Take this forward. And it wants a rational. So the first one says, write a rational expression that has given restrictions as its non-permissible values. So it has x can't equal 0. So let's think about that. If I have x can't equal 0, what operations can get me 0? What could I put in the denominator? I could put just an x. So an example could be like x plus 1 over x. Or I could have went like 3 over x. That would still work. We agree? What other things could I put on the bottom that would get me 0? Instead of x, I could do x squared, x cubed, x to the 100, right? So I could go like x plus 1 over x squared. I could go 3x minus 2 over x to 100. I could add any coefficient I want in front of this. I could put a 2 here. Because does the 2 actually affect it? No, the 2 would go in its own bracket. So it would be like this. So that's an example of what I could do for 4a. When your non-permissible value is just 0. What happens when your non-permissible values are a can't equal 0 or 3. Do you see how they use the variable a? You can't be like, I don't like a, I'm using x's. You can't do that. Okay? If they give you a's, you have to use a's. So let's think about it. I have two MPVs. I have a can't equal 0, and I have a can't equal 3. So to represent 0, I can pick a. I could just put an a in the bottom. We agree? Or an a squared, or an a cubed. Like I could do another option. I could do like a cubed. And that would represent 0. We agree? What do I have to state for my MPV if I want a can't equal 3? What would it have been? Yeah. So we're working our way backwards. Remember they were equal to 0 before and we solved them down? Now we have to get them back equal to 0. So I can subtract the 3 and I get a minus 3 can't equal 0. And that's what I have to use. A minus 3. And then I can do whatever I want on the top. I can put a 7, put a negative 7. Or I could put a minus 3 even. It doesn't matter what I put up there. It just has to be a number or like a nice factor or something like that. I want you to try C. C is negative 5 and 0. Try it out. C has x can't equal negative 5 or 0. So I can do, to get the 0, I can do like x to the 4th. Sure. I can even put a 2 in front, because does that change anything? No, I could put a negative 17 there. It really doesn't matter. It doesn't have a variable. Then I have x can't equal negative 5. If I work that back, I add 5. So I'm going to get x plus 5 can't equal 0. And if you're allowed to do whatever rational you want, I go like this. I'm not a rebel. I just put a 1 up there. They're not making me do anything fancy. I'm like, thank you. I'll put a 1. I know I can't get that wrong. And then D is the one that I would star if I were you, because it's the one that's done the poorest, because it's a fraction. It's just a bit harder. So D has A can't equal 1/3. Now what some people try and do, I don't know why this computer hates me. They try and subtract 1/3. Don't do this, it's wrong. So they go, A can't equal negative 1/3. Or sorry, A minus 1/3. Don't do this, it's wrong. Can't equal 0. Have you seen a rational like that yet? No. When we got fractions way back in the past, when we had fractions, I'm going to go back way up here. To here. This one. So do you see how, nope, you don't, because it just moved itself. So here I got t can't equal 1/3. The original was 3t minus 1. Remember when you get fractions, you actually have a coefficient in front of the t. That's all that ends up happening. Well, how do we get that back? Well, we still just try and get our variable equal to 0. So we have, you can write this down, this is going to be right. A can't equal 1/3. That's what's sitting in front of us, right? That's what it says. Well, how do we work our way back? Well, the other ones we just added or subtracted and worked our way back. Here we actually have to split the third up into 2 operations. So what are we going to have to do? We're going to have to get rid of the 3 first. The 3 is being divided. Do you see that? We're going to actually multiply. Let's move it over. So now I have 3a cannot equal 1. And now I can subtract the 1 over. So you have to do it in 2 steps when it's an MPV, that's a fraction. You have to multiply first, then add or subtract. So I'm going to get 3a minus 1 can't equal 0. So that's what has to be in my denominator. And if they're not being specific, I'm going to do this. If they're allowing me to do whatever I want, I will put a 1 in the numerator and call it a day. I'm not going to do anything fancy. I'm a math person. I won't even like try and make things cancel. I'm just going to be like 1. Can't error if that happens. Okay? I'm going to get you guys to open your notes up to multiplication. You have to pay close attention because if it says simplify, that can be the headline to adding, subtracting, multiplying, dividing, or just plain old simplifying. Now, how do we know what they're asking us to do? By the operation that's in between them. So like closed off, that's a multiplication. If there's a division symbol, you're dividing. If there's an addition symbol, you're adding, right? So that's one way to tell too. Now, whenever it is, there's 3 options. If it's just a simplify like we did on Friday. So on Friday, we had a numerator over a denominator. That was it. That's a basic simplification. Or if it's a multiplication or division, you will follow all of the same rules. The first step that you're going to do every single time, if it's multiplication, division, or a basic rational, where it's like a top and a bottom, the first step is GCF, difference of squares, every numerator, every denominator. That's your first step. GCF, difference of squares, every numerator, every denominator. I find if people can do the right first step, they can usually do really well. It's just getting that first step, remembering what you need to do first. Okay? Adding and subtracting, our first step is going to be getting common denominators. But for multiplying, dividing, and just a basic simplification, one over the other, our first step is GCF, difference of squares, every numerator, every denominator separately. So let's look at the first one. We have example 1, simplify the following rational expressions and state non-permissible values. So our first numerator on the left is x plus 1. Can I take out any GCFs, or is there any difference of squares happening to that? X plus 1? Can I do anything to it? No. So, is the x sewn to the 1 by a plus sign? Yes. If the x is sewn to the 1 by a plus sign, we put brackets around it. So that's all I can do with that first numerator. I can go x plus 1 in brackets. Make sure you have equal signs running down, each rational expression equal to each other. Then the next one, I have x plus 3. X plus 3. Can I do anything to the x plus 3? Is there a GCF or a difference of squares? No. Is the x sewn to the 3 with a plus sign? Yes. So I put it in brackets. That's how it knows that it is. You try GCF, difference of squares, the top right and the bottom right. So the top right, we have 2x plus 6. What can we take out? A 2. If we take out a 2, we're left with x plus 3. And this 2 sitting in front can go in its own bracket. Remember? The number that sits in front can go in its own bracket. The bottom right, or the denominator on the right-hand side, what can I take out of it? Just a x. X squared divided by x is x. What's x divided by x? 1. Anything divided by itself is 1. Not 0. It doesn't go away. Anything divided by itself is 1. So I'm going to get a plus 1. And the x is just sitting out front so it can go in its own brackets. Okay? That's step 1. Multiplying, dividing, simplifying. Just one over another. The first step is GCF, difference of squares, every numerator, every denominator. Okay? Second step for all of them is state non-permissible values, because we always have to state non-permissible values before we cancel. Okay? So if I'm like, ooh, there's things I can cancel, I'm like, no, stop. State NPVs first. Okay? If you state the NPVs after you cancel, you'll be wrong every time and think you're right, because they'll have the answer there to the simplified NPVs, which is completely incorrect. NPVs have to be stated before you cancel. So first step is GCF, difference of squares, all the numerators, all the denominators. Second step is non-permissible values. How many brackets do I have in the denominators? 3. How many of them have variables? 3. How many NPVs am I going to have? 3. The number of brackets with variables equals the number of NPVs I'm going to have. So I say NPVs. And I have x plus 3 can't equal 0. I have x can't equal 0. That one's done already. And then I have x plus 1 can't equal 0. I'm just taking the 3 separate brackets and putting them not equal to 0. Now the x plus 3 can't equal 0. What do I have to do? Subtract 3. So I get x can't equal negative 3. That one's done. And then I get minus 1. X can't equal negative 1. So step 1, step 2, there are only 3 steps. Ready for the third one? When you multiply 2 fractions together, you always multiply numerator times numerator, denominator times denominator. We agree when you multiply fractions? So if it's like a quarter times 3/4, you would get 3 over 16. You multiply top times top, bottom times bottom. So your third step is to just do this. Draw an entire line through. Because that just shows that all the numerators are being multiplied together and all the denominators being multiplied together. So now you have one numerator, one really big numerator, over one really big denominator. You see that? Anything on the top that is a twin with anything on the bottom can now cancel because I stated NPVs. I can't cancel them until I state NPVs, but I'm done already. So what matches? X plus 3 matches completely. X plus 1 matches completely. Then I have a 2 and an X. Do I have anything that matches those? No, so that's as good as it gets. So my answer is going to be 2 over X, and then I'm going to state my NPVs behind it. X can't equal -3, -1, 0. So step 1, GCF difference of squares, all the numerators, all the denominators. Step 2, NPVs. Step 3, draw a big line and cancel. Done. That's it. 3 steps. If you do those same 3 steps every time you multiply, divide, or simplify just a something over a something, you will get every question right, always. There's nothing more advanced than that. That's it. So let's look at B. B, the left-handed numerator, so left-handed top one is a monomial. What do I do when I have a monomial? Bracket, bracket. I just bracket everything separately, right, when it's a monomial? Monomial meaning one term, no plus or minus signs. So I get a 12 in brackets and an x cubed in brackets. The left-handed denominator, just open it. The left-handed denominator has 3x squared plus 6x. What's common to the two of them? What's common to 3x squared plus 6x? 3x. So I can take a 3x out. 3x squared divided by 3x is x. Plus 6 divided by 3x is plus 2. And this 3 and this x are not connected by plus or minus signs, so they can go in their own brackets. Then I have a multiplication dot. Now sometimes they use multiplication signs. If I have a choice, I will always use a multiplication dot because most often the variables are x's and a multiplication sign looks like an x. And that just causes mass confusion. So I just do dots. Okay, numerator on the right. What can I take out of the numerator on the right? 4x squared. 4x cubed, take out 4x squared, I'm left with an x. Positive 8x squared divided by 4x squared is a plus 2. And the 4 and the x squared are not connected by plus or minus signs, so they can go in their own brackets. And the right-hand denominator is awesome. It is a 5. I just put it in a bracket. So, my first step is GCF difference of squares. All the numerators, all the denominators separately. We agree? Second step is non-permissible values. So I have to look and say, how many brackets do I have in the denominator? I have 4. How many of those 4 have variables in them? 2. How many NPVs am I going to therefore have? 2. It's always equivalent to the variables, because variables are what causes NPVs. So is this 3 going to cause me an NPV? No. The 5 is not. Those don't have variables. It's just the x and the x plus 2. So my NPVs are going to be x can't equal 0, and then that one's done. And then x plus 2 can't equal 0. Subtract 2. X can't equal -2. So we're done 2 of 3 steps. We've actually completed the hardest part. Sometimes simplifying is the hardest part because people don't cancel the right things. But we'll practice that. So step 1, GCF difference squares, all the numerators, all the denominators. Step 2, NPVs. Step 3, make a full numerator, full denominator by drawing that line connecting itself. Because the numerators multiply by the numerators, the denominators multiply by the denominators. Does anything on the top match anything on the bottom? Yeah. The x plus 2 is the most noticeable. The next thing to see is I have an x cubed and an x squared on the top, which means I have 5 x's on the top. Do you see that? Those can't cancel each other off. They're both in the top. We agree? I have an x2 and an x3, which means I actually have 5 x's on the top. How many x's do I have on the bottom? I have 1. We agree? I have this one right here. And up here I have a total of 5. Well, I can take this 1 off for one of those x's. So I can either cross the x off here and make it x squared, or cross the x off here and make it x to the 1. But I can only do it to one of them. Because I have 5 total on the top, 1 on the bottom. I need to have 4 total on the top once I'm done simplifying, correct? It's like a 1-for-1 deal. So this 1 can either cross this off and make it a 2, or cross this off and make it a 1. I'm going to cross this one off and make it a 1. But you could cross the x cubed off and make it a 2. But you can only do it to one of them. Is there anything else that can cancel? Numbers? The 4 and the 5 can't cancel. Nothing can come out of those. 4 and the 3 can't cancel. 12 and 5 can't cancel. What about 12 and 3? I can take a 3 out of both of those. Do you see that? So I can look at any numbers on the top and see if they're divisible by any numbers on the bottom. The 12 and the 3 are. 12 divided by 3 is 4. 3 divided by 3 is 1. Now, worst case, you don't delete enough stuff. You don't cross off enough stuff, right? In the next step, when you're done it, you see you can still cancel more. Can you just do one more step and cancel more? Yeah. Worst case scenario, you do an extra step. It's not the end of the world, right? So let's write what's left over. When we have more than one number in a bracket by itself, we just multiply them. So 4 times 4 is 16. And then x cubed times x to the 1, 3x's plus 1 more x is x to the 4. All over 1 times 1 times 1 times 1 times 5. So it's just a 5 in the denominator. And I have to make sure to state my MPVs. So x can't equal 0 or negative 2. You're going to try C. The hint to C is the bottom right denominator is a difference of squares. Try it out. Okay, the top left, what can I do to it? Take out a 2x squared. 2x cubed, take out 2x squared is x. Negative 4x squared, take out negative 2, or take out 2x squared is negative 2. And then the 2 and the x squared can go in their own brackets because they are multiplied. If they had an addition or subtraction sign, they would be connected. Then I have 3x squared minus 9x, which I can take out a 3x. When I take 3x out of 3x squared, I'm left with an x. Minus 9x divided by 3x is 3. And then brackets around the 3 and the x because they are attached by multiplication. The top is an x squared, and it's just a monomial, so it goes in its own brackets. The bottom is the difference of squares. The square root of x squared is x. The square root of 4 is 2. So I get x plus 2, x minus 2. Before I go to cancel it off, or before I go to make a line through it, I do GCF difference of squares to the numerators and denominators, step 1. Step 2, non-permissible values. I have 1, 2, 3, 4, 5 brackets, but of the 5 brackets, only 4 have variables. Therefore, I'm going to have 4 non-permissible values. The 3 doesn't cause me one. X can't equal 0 is one of them. X minus 3 can't equal 0. Add the 3. X can't equal 3. X plus 2 can't equal 0. And x minus 2 can't equal 0. So now subtract 2. X can't equal negative 2. So I'm going to add the 2. X can't equal 2. First step, GCF difference of squares, the numerators and the denominators. If you haven't heard this over and over and over again, it's because it takes sometimes 10 to 15 times of hearing the same thing till it actually goes to long term. So I'm going to keep doing it like 777, and therefore we'll lock it in, okay? First step, GCF difference of squares, all the numerators, all the denominators when I have simplification, multiplication, or division. Step 2, non-permissible values. Step 3, if it's multiplication, we do full numerator over full denominator. Then I cancel what's the same. So I have an x minus 2. Here I have an x squared and an x squared, so the whole numerator has 4 x's. The denominator has 1 x. So I can take 1 out of 4, so I should still be left with 3 on the top when I'm done canceling, correct? So this x can cross off one of these, or it could cross off one of those. I don't really care. Then I think I'm as reduced as I can go. If I'm not, I'll catch it in the next step, and I just do another step and reduce. It's not a big deal. It doesn't matter. So let's see what's left over. A 2. And then an x times an x squared is 3x's, so I get an x cubed, over 3, x minus 3, x plus 2. Sometimes it does not get better than this. People want like 2 over x as their answer. That's great that that's what you want. That's not always what you get. Okay? So sometimes don't freak out if not everything canceled off. It doesn't always. Okay? And then I have to follow behind with my MPVs. X can't equal 0, 3, plus or minus 2. Now you guys try the or term. So this one, we can take a 2 and an x out. And we're left with x minus 6. The 2 and the x go in their own brackets because they're multiplied. 15x is a monomial, so the 15 and the x go in their own brackets. Times 5x, it's a monomial, so 5 and the x go in its own brackets. And then x minus 6. So I have 3 brackets in the denominator, however, only 2 have variables. So my NPVs, I'm only going to have 2. I'm going to have x can't equal 0. And I'm going to have x minus 6 can't equal 0. Add 6. X can't equal 6. Now, if you're lost, like you're in Narnia lost, if you don't know what you're doing right now, I can't tell. Like I walk around and you can say fudge stuff, or I don't know. Sometimes it's like you're literally just not doing it, or if you're like lost in Narnia. If you are, the way for me to know is for you to walk up and be like, Lepp, Narnia, and I'll be like, yeah, I get you, and then we'll work together so you're not lost. Because sometimes the test comes and people still kind of do NPVs, and I didn't know they were that lost. Like I walked around and I'm like, are you lost or are you lazy? I don't really know, and I don't want that to be the case. I want to know. So you can just like walk up and be like Narnia, and I'll be like, yes, wardrobe, which, fine. Yeah, and then we can work on the problems. Rather than you just giving a 0, it's just Sam. Okay? Narnia's a good place to be, I hear. Not when it comes to math problems. That's scary. Okay. First step, GCF, difference of squares, all the numerators, all the denominators. I'm getting annoyed with my own self. And then step 2, NPVs. Step 3, draw a middle line. Connect both sides. It is fun. There. Ooh, see, look how much fun it is. Like, you're like, math's not fun. That is. It's almost equally as fun as, like, snowboarding. Fair, same. Equal. So, x minus 6 cancels, and x can cancel off one of them. It's not a 3-for-1 deal. It's like a 1-for-1. And then if, okay, I'm going to be a rebel without a cause. I'm not going to cancel it as much as I possibly can. Watch me. Watch me. It's not the end of the world if you don't. That's all I'm proof. So, I think I'm done. I'm going to write 2 times 5 is 10 and an x. And in the bottom I have 15. And then I get really mad at myself. I'm like, you idiot, you didn't cancel them all off. How dare you? No, you don't get mad at yourself. You just go, dude, I got 5s I can still take out. And you take them out and you move on. That's what you do. You don't get angry. You don't get sad. You just do one extra step. Use a little more pencil. What's the worst that can happen? A little less pencil? Not a big deal. A little less paper spots? You wouldn't have used that paper spot for anything else. Who cares? Watch. I have people who are literally depressed when they have to do an extra step. I promise. You are okay. Watch me. 10 divided by 5 is 2. 15 divided by 5 is 3. I'm still okay. Look at me. Totally fine. Narnia. 2x over 3. Now I'm done. Had I noticed, I could have taken a 5 out of here and did a 3 and a 1, right? But so I don't. Who cares? Do it in the next step, right? Sometimes it's actually harder for people to cancel it here. So I tell them to not cancel it there, put them together, and then cancel it here. I would rather you do an extra step and not mess up, which is honestly, a lot of people struggle canceling them off here. It's totally fine. If that's you, don't do it there. Do it here. Do an extra little step. No big deal. Okay? And then x can't equal 0 or 6. So here is your homework you're going to work on. And I'm going to check it tomorrow because I'm cool like that. And I need you to practice. It's on one of these boards. This is out of the textbook. So what I would suggest you do is go to the textbook, page 238, 239, paying attention, page 238, 239. The textbook is the one below the workbook. It's on that wall over there. You can just grab one. Even one person can do this. You can be the good friend that everyone likes. Page 238 and 239. Take a picture of that. Do you see that? just those 2 pages, and then go to the back of the textbook and take a picture of the answers, which is 1 sheet, maybe 2. Picture of answers. Then text it to your friends. You don't take a textbook with you. So you can do 1 and then have people message you of it, or you can all take a picture. I don't really care. But this is your homework. You need to write it down, and you have some time to work on it. So you could do this. You could work into scheduled help, whatever you want. But I'm going to come around and check that 2AB, 5ACD, and 6 are done. And honestly, please check your answers. I have so many people who think they rock at rationals because they never check their answers. But if they just checked their answers, they would see that they have none of the same answers as the back of the book. Yes. Little flying parachute, guys.